We are told that the graphs of r equals 3 and r equals 3 minus 2 sine theta are shown, and we're trying to find the area of the shaded region. I'm going to start this one off by just showing you guys the answer that was on the rubric. And I will also, there's alternative answers that are also correct, but regardless of how you do this, this is the answer you should end up with once you calculate it all out. If you're watching this video, it means you're having problems knowing what to do, which means likely either you don't quite understand how the area is being swept out, or you've forgotten some formulas that are important. When we're dealing with a polar function, the area is going to be found by taking 1/2 of the integral for some specific angles of r squared d theta. And what we're going to have to do is try to figure out which of these, how this shaded region is being formed. If you graph these on a graphing calculator, you're going to find that the graph of r equals 3 is this half circle, and it would start over here where theta is 0, and as theta increases, the circle gets traced out, but it's always 3 away from the origin. And then for the other function, this r equals 2 minus 2 sine theta, when theta is 0, it's going to start over here where theta is 0, and as theta increases, it's going to sweep out like this. And what we can see is that right at this point, the blue graph is taking over, was defining the region, and the green graph gives up control. The way we find these theta values that they're using are by thinking about how this first part gets formed. And what I'm picturing myself is like a radar sweeping through, or something where, if you could imagine like a straight segment that's then being rotated this way, and it's going to sweep out in that kind of manner, and we want to figure out what these theta values are. So it's pretty clear that they're going to start at 0. That's why they have the 0 down here. And it's pretty obvious too that it ends at pi over 2. That is the place where these two graphs intersect. But I'll say if you are not feeling confident about that, or if you had a problem where you weren't quite sure where one function was picking up and the other one was leaving off, you would just find that correct theta value by setting these two functions equal. Since it says r equals this and r equals this, we can simply set this 3 equal to this 3 minus 2 sine 2 theta, and then if you were to solve that problem, solve that equation, the theta value you got would be the theta where where the graphs intersect. This portion of the answer that they have, they got this by assuming, not assuming, but by knowing that this blue portion is defined by a circle whose radius is 3, and they only have 1/4 of that circle. So they took 1/4 of pi times the radius squared. But I'll say you also could say that this blue portion happens when theta is at pi over 2, and theta is going to continue until theta is down to pi. So you, instead of doing what they have there in green, you could also have done 1/2 of the integral from pi over 2 to pi of the function 3 squared d theta, and then of course adding this part in to get this answer of 9.708. So at the end of the day, it's all about knowing this formula and then understanding how these areas are being swept out to get the answer.